Hi, so this is the video for problem 1 of ESE403, midterm 3. So first, let's go through the problem. The problem is about the company that is required to meet the standard of the reduction in annual emission rate of the 3 pollutants. Here we have 4 tables. Table 1 is about the required reduction rates from the policy. Table 2 are like the efficiencies of reductions for 6 different approaches, and table 3 are their corresponding costs, and table 4 are the variable names used for these 6 approaches respectively. And so let's see the problem part. For part A, we need to formulate a model and use IBM Doc to solve it, and also cast a sensitivity analysis. Here's the problem that I formulated. We can see here are the restrictions from the policy standard, and we also use the corresponding cost of the 6 approaches to formulate our objective functions. Our objective is to minimize this problem, minimize this price, sorry. And also for the IBM Doc code and the sensitivity analysis, I've shown them below and copied them here for convenience. We can see the code is consistent with the problem that I formulated, and we can use the extra tool in IBM Doc to do the sensitivity analysis efficiently. Here we can see the shadow prices and the lower and upper bound of the sensitive range. And for part B and part C of this problem, we have to recognize which are the sensitive parameters in these problems, because we are notified that the numbers in table 2 and table 3 are not very accurate. For part B, we mainly want to focus on the B values. For these B values, it is very simple. We only need to see which of those B values have their shadow prices not equal to 0, because this indicates that if the values of them change, the optimal solution might change as well. So we can identify that for B4, B7, and B9, they have their shadow prices not equals to 0. And also we have B1, B2, and B3, but since these are fixed values, they are from the policy standard, we do not consider them as parameters that need more accurate estimation because they are fixed. And for part C, we know from the problem statement that there might be a 10% discrepancy, either 10% more or 10% less for the values here, because the company is not that familiar with their new approaches or something. So we only need to compare the 10% less and 10% more ranges here with the sensitive ranges here we obtained from the sensitivity analysis to see which of the values might be over this 10% ranges. And we can tell that C1, C2, C3, C5, and C6 either have the 10% more restriction violated or 10% less restriction violated. So these 5 values, these 5 parameters should be estimated more closely. And let's see for part D here, part D. So for part D, we need to construct a maximization version of this problem and also compare what is the difference between their two problems. So let's see, when we convert a problem from minimization to maximization, all of the sign changes, not only for the plus sign and minus sign in the restrictions and objective functions, but also for the smaller than equals will turn into larger than equals and vice versa. And also we can see the optimal solutions, they also have their sign being opposite to the original values. And also for their dual problems, since when we convert a problem from this primal one to its dual ones, we already have our this sign changes from smaller than equals to larger than equal to. Then for the minimization and maximization version of this problem, they will also have their dual problems with opposite signs as well. So as I described below, this is just what I said. And let's see, for part E, we have to specify the rate at which the total cost might change, right? So basically, we only need to read from the sensitivity analysis of part D, which is shown below. Let's see. Yeah, it's here. Yeah, so we can basically just read from the dual prices of C1, C2, and C3, which indicates the 3 different pollutants, and copy them here. These are what we want for part E. This is like the rate of change in the cost, and also the maximum increase and maximum decrease. I just to like use the values of the ranges limit to find the difference between the max value and the mean values and the current values. And let's see, for part F, we want to see like how we make like a trade-off between different pollutants. So basically, after we have already known the rate of change in cost of these 3 different pollutants, all we need to do is just like to divide one by another. For particulates and sulfur oxides, just like divide and got the corresponding like unit changes in the opposite direction. Notify that this is like in opposite direction because we want to keep the total cost the same. And for particulates versus both other pollutant, we only need to like add them together and then use this value to divide it. Okay, so let's see, after part F, for part G. Part G, we want to use this theta to denote the percent change in all of the policy standards, because we have learned from the problem that with each like 10% increase in all of the policy standard, the company can get like a tax reduction by $3.5 million. So the company might consider like change the objective function, change the problem formulation a little bit to find what is like the optimal solution, like considering the tax reduction, like whether they want to like provide more capacities of the reduction in emission rate to like get treatbacks for like a reduction in tax. So we change these problems to see like the policy standard for the restrictions are each added by like 0.6 theta, 1.5 theta, and 1.25 theta, like correspondingly proportional to their original values. And also we have our objective function minus by 0.35 theta, because like this theta is in like 10, 20, 30, 40, 50, and for each 10%, we got like a 3.5 million changes. And we just need to like maybe like resolve this data to find like the answer to the problems below. And here we need to find the rate at which the optimal total cost would increase with like a small increase in theta. This is basically just to use the values, use the like the shadow prices that we found it above to times by the increase in each of the policy restrictions. Then we can get like what is the total cost increase in these values. And from part H, we want to use the IBM doc to find which of the theta's values will give us like optimal total cost, considering the compensations in the tax reductions. So basically, we just use the IBM doc with our new formulated questions. Here, I won't show them all, but you can see for each of the problems here, we got like different theta values. Here's 20, and here's like 30, and so on. And then we copied all of the results from the IBM doc above and compared them and reach our conclusion that when theta equals to 40, we have our minimum total cost. Then for part I, it is very simple, just to repeat part E and part F. We already obtained our like optimal solutions for theta equals to 40%. So basically just do the sensitivity analysis again, which is down below here. Let's see. Sorry, there's a little bit long. Yeah, here. So basically just do the same thing and copy like the sensitivity range and the shadow prices, the reduced cost here. And basically just do the same thing that we did in part E and part F. Yeah, here. So these are the rate of changing cost for 3 pollutants, and these are their like sensitivity ranges. And basically just use the same trick, like one divided by the other, to find the unit changes in the opposite direction. So that's all. I hope my explanations was clear enough to help you go through my problems, like of how I solve these problems. So thank you.